Estonians of all country where the ASV conducts its business, and pay my respect to them, their culture and their elders, past, present and emerging. Thank you everyone for coming, both in person here at Muir Hall tonight and online on Facebook, YouTube and Twitch. Tonight, we have the privilege of having Mr. Duane Hamacher, who is an Associate Professor and Director of the Cultural and Indigenous Astronomy program in the School of Physics at the University of Melbourne. Duane's work examines humanity's connection to the stars, our presence in space in terms of science, history, culture and society, with a focus on Australian Indigenous astronomy. He has published 60 plus papers and chapters. These publications include the best-selling book, The First Astronomers, How Indigenous Elders Read the Stars, in collaboration with 6 Aboriginal and Torres Strait Islander elders. Tonight, Duane will be talking about Aboriginal observations of variable stars, from pulsating giants to supernovae explosion. Aboriginal Australians have kept detailed oral records of stellar observations for long periods of time. These records indicate that people observed variable stars and assigned them meaning. In this talk, Duane will detail the process of conducting this research, showcasing the methods and challenges with analysing information that comes from both scientific and cultural perspectives, where we will explore stellar scintillation, pulsating variables and cataclysmic variable stars. After Duane, we'll have our monthly presentation of what's up in the sky for February from Bill Stead. But let me move straight on and introduce Duane.
Thank you. This is on, all right. Thanks for the invitation to come speak. It's good to see about half the audience is my research group, so well done. I am keeping tabs on who's here. I would like to say that what I'm going to do today is a little bit different than just giving another lecture, right? I'm going to have a little bit of participant activity going on. So what I would like to ask, can we turn the lights on a little bit for just a second? All you socially awkward people who like to sit in the back like me, come forward a bit, because I'm going to need you, like, interaction here. It's not just me talking at you. Come on, do it. This is not a Gallagher show. I'm not going to be smashing pumpkins up here, I promise. All right, there we go. We're making progress. Excellent. So what I wanted to do is take us on a bit of a journey on how we actually do research in this kind of area. Is this really loud? Very echoey? Pull it down a little bit. I'm American, my voice carries anyway. You can let that out. Okay, thanks. So I probably won't get to the cataclysmic stuff today, but what I wanted to do is talk a little bit about the work, set some foundations to it, and show you some of the primary sources and actually kind of go through the process of research together. I mean, yes, I published research in this a long time ago, and oftentimes when we give talks about this, we're talking about our findings, the results of what we have. But what people don't understand is how we come to know what we know or what we think we know. It's really important that we go through the process. So I think Mark messaged me like a week ago when I was on holiday and says, can you come give our monthly talk? I'm like, yeah, sure, whatever. Have another beer. And I'm like, oh, hang on. I'm giving a talk. So it's a great opportunity to come and sort of jump into this. Now, the study of variable stars themselves is quite interesting. It's where I first got into my graduate level of research. So in 2006, I had moved to Australia from the US to do a PhD in astrophysics at the University of New South Wales in Sydney. And when I came here, I was doing my thesis on transiting exoplanets. So searching for planets orbiting distant stars. But the technique we were using wasn't radial velocity, it wasn't microlensing, it wasn't direct detection. It's what is now the most popular or widespread method, which was to see if there's a bright star in the way, there's a bright star, and if a planet happens to move in front of that, and you measure the light of that star over time, you're going to see that light dip by a little bit. So if you have a star like our sun, and a planet like Jupiter, and it moves across, it'll make that light dip around 1%. So that is looking at a variable star. So as you're going through, we actually had this automated patrol telescope. This is half-meter, formerly military-use telescope that was tracking satellites that we had developed into this automatic survey telescope we had up at Siding Spring Observatory in New South Wales to help build up this exoplanet survey. Now, at the time, exoplanets was still a relatively new area. I think only 4 or 5 planets had been discovered using that technique when I started. I think when I submitted my thesis, there were 40, and by the time I got my results back, there were like 70 that had been discovered. It took off very quickly. But during that time, we would photograph fields of stars, and then with each of those photographs, we'd stack them on top of each other to have like a time, so you could look and see their brightness over long periods of time. And we would do that each set for a couple of months, and we would move to a different field. And at the time, we didn't have an algorithm or a piece of software or AI to go through and search for them for us. We had to physically eyeball them ourselves. So what it would do is it would bring the stars up, it would put an aperture, a circle around where the star was, it would measure all the light off of the CCD chip, all the photons that would hit the CCD, and then create these light curves. So for stars that didn't exhibit any changes in their brightness, it would be a straight line. There's a little bit of noise in there, but it'd be pretty much a straight line. And we were looking for these little tiny dips in there that have a very specific kind of geometry. So what we'd have to do is one field would have a couple thousand stars, and you're sitting behind your laptop just going like this, click, 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 and just looking at these light curves that's generated and seeing if you notice any patterns in that. Not the most scientific process there is, of course. The challenge was that there are lots of stars out there whose brightness changes in weird ways. And initially, I didn't care about those because that was all junk to me. All I cared about were finding these. And it took a bit of time. And you look at a light curve, it would look something like this for a planet. So you'd be looking for these signatures, but you couldn't help but notice some of these looked really freaking cool. Like some of these graphs, these light curves looked really bizarre. And over time, if you weren't finding a planet, you kind of had to have something else to do with your time and research. We began realizing that a lot of these variable stars are really interesting. They tell you a lot about the physical structure and evolution of these stars, about their lives. And that became more of a focal area of doing the research. So I spent a long time doing that, about 2 years. But I also grew very frustrated with that area. It wasn't exactly the most entertaining thing for me. It wasn't really what I wanted to do. So I left my PhD program and did a master's instead. And then I wanted to do something different. Now, what I did was, of course, was Aboriginal astronomy. And I enjoyed that. But that knowledge of variable stars and that expertise I gained in that process came in handy later on. And that's what we're going to get into now. So as we're discussing variable stars, it's important to understand the different types of them. Not only what they look like in terms of astrophysics, that's not really the part that I'm interested in. What I'm interested in is can we see them? What are they going to look like? And did cultures ever observe them? And how did they assign them meaning? How did they observe them? And if they did or were doing research, how do we know? Like, they wouldn't have said variable stars. It would have been coded in a different kind of language. So the first kind of variable star, and one that we're going to be focusing on today, are pulsating variables. These are intrinsic, so that you have intrinsic stars, and pulsating tend to be the general kind. There's pulsating, and there's cataclysmic stars, the eruptive variables. These intrinsic variables, something within the internal structure of the star is causing its light to change. So the stars might pulsate, they might get bigger. When they get bigger, they get hotter and brighter, and their brightness increases, then maybe they come back down again, and that decreases. You've got Cepheids and Aura Lyras and long-term variables, all these kinds of things. And then the others, which I don't think we're probably going to have time to get into, are the cataclysmic. These are your nova, your supernova, your Eta Carina type stars. And boy, they can give you some interesting looking light curves when you see them. And it's kind of amazing to look and understand the physics of the star just by looking at its light curve. So these we call light curves for kind of obvious reasons, but this in astronomy is a technique you know as photometry, measuring the light of something, as opposed to spectroscopy where you break it down and measure the spectra. So if you're doing astrophysics research on exoplanets, for example, if you find that there's one of these planets that's transiting its star, you can actually do spectrographic analysis of the star and see if the spectrum moves back and forth as the star tugs, or the planet tugs in the star and back and forth. But you start looking through these and you learn about all these kinds of interesting variable stars. The other one that's quite interesting, and there is some historical studies about these types of stars, are very similar to what I was doing on transiting exoplanets. These are extrinsic types of variables. This is where something outside the physical structure of the star causes it to change in brightness. Most common being two stars orbiting each other, and they just happen to move in front of and behind each other. This makes their light dip. You can get eclipsing binaries, and you can get rotating variables. These are basically stars with gigantic sunspots on them, and as they rotate, because part of the star is dark, it seems dimmer. These were the ones I was most concerned about when I was doing my exoplanet research, because if you get a really big bright star and a smaller, fainter star, they can mimic the exact same shape as a transiting exoplanet. But there's certain things you have to look for in that. And I just wanted to put this up because I think this is actually an amazing area of research. And it's an amazing area of research that the amateur astronomy community can really get onto. It doesn't take a lot these days to get your telescope set up to do these kinds of surveys, and you'd be amazed at how many crazy variable stars are out there. Do you guys do anything like that on variable star research at ASV? Little things in their own, but there's some amazing stuff that can be done here. And there's so many stars that are within a reasonable field of view. You don't need some giant meter class telescope, even though you guys have that anyway, right? You can do these with relatively small telescopes. Even strong cameras can do this kind of stuff. What I just found interesting is I would see some of these light curves that just look like a sine graph. And these were your close orbiting binaries where the stars would actually cross their Roche lobes and blended into each other. Really wild stuff, but pretty cool. Okay, I've talked a bit about variable stars and a couple of different types of them. But why is this important? Well, the study of variable star astrophysics, like understanding that stars change in brightness, is a very recent branch of astrophysics. Only about 150 years old, and only really has taken off in the last 100 years or so. And in particular, since we started looking for exoplanets, we find more variable stars than ever now. But why did it take so long? So, some curious things. Most of the stars we see in the sky are variable, a majority of them. That doesn't mean you're going to notice their variability. The changes are either too small and or they have such long time scales you're not going to notice them. But there are stars in the sky that do change in brightness, and they potentially could be noticeable. Some of them change subtly, some of them change significantly, and others change so much they go from being a visible star to being an invisible star and back again. But one of the reasons so much time passed before anybody really took this seriously wasn't purely because of this guy, but he was one of the main reasons for it. He argued that the cosmos were invariable and unchanging. There was this perfect harmony in the sky. There was a beautiful sort of divinity within the stars that meant they didn't change and little things didn't happen. That kind of stuff is what happens down here, the profane universe that we live in. It doesn't happen up there in the sacred, divine, celestial realm. Now that philosophical position, which became a theological position, very heavily rooted in Western civilization over the last couple thousand years, dominated. As many things in astronomy did, even though you could see evidence to the contrary of that, you didn't dare challenge it because we know what happens when you challenge the theocratic doctrine of the day. Galileo being one of the more famous examples of that. But eventually you started to realize, people started realizing that, yeah, there's weird stuff happening in the sky. One of those that is the most significant is the variable star Mira. So what I've done here is I've shown a light curve of this. You can see the star sort of getting bright and then getting dimmer. Of course, I think most people understand the really bizarre magnitude system of stars, where the brighter it is, the lower the number, and that they're logarithmic. So what I've done here, the number 2 here would simply mean that it's brighter, and the number 10 means it's very faint, right? So what you look here, you see this red line. That red line is the approximate threshold of our visibility. What that means is it can get up to about a 3rd magnitude star, sometimes a 2nd magnitude star, but usually around a 3rd to 4th magnitude star. So noticeable, nothing crazy. It's not like the brighter stars in the sky, but you definitely see it. And over a relatively short period of time, it completely disappears from view and goes well beyond the threshold. Even people who could see magnitude 7, maybe a bit lower, it dips below that. So here's something where a star appears relatively bright and then completely disappears. If you want to know, we're looking at 1990, 1970, 1950, so we're kind of going in 20-year increments, thereabouts, in time. So you can notice these changes. This is the more obvious one. Now, it was David Fabricius back in 1596 who had noted this, but it was Johannes Helvelius that really calculated the periodicity, the time that would go between these peaks or troughs. And he would note that, and they're kind of credited as the discoverers of that, even though it was separated by about 70-odd years. But this is one of the first times in history, in the history of Western astronomy, we've got a clear example of stars changing in brightness over time, and that being not a subtle observation, but a very obvious one. Another one, which is quite interesting, is a star Algol. A lot of ancient cultures referred to Algol in very weird ways. It was often linked to a sort of demonic type of star. Some of the old terms for this, both in ancient Arabic and in Vedic languages, meant, in some of the Vedic languages, I forget the name of it specifically, but it meant changing at its own desire. It was seen as the winking eye of the head of Medusa held by Perseus. Now, it was John Goodricke back in 1783 who is credited as the formal discoverer of this star changing in brightness. Now, this star has a rather peculiar thing. Every approximately 3 days, it will dip in brightness by a fairly noticeable amount for several hours before coming back up again in brightness. And this was sort of one of the ideas where it was never directly said that this star is changing in brightness, but it always seemed to be inferred in the historical documents and in the way it was described. Changing at its own pleasure, winking eyes, having some kind of evil link. And the reason an evil link is important is when you look at astronomy in cultural terms, things changing in the sky is considered bad. The stars work as a sort of permanent, stable element to our world. Things down here change all the time, weather changes, environment changes, but the stars are sort of our link to stability in the cosmos. So things that would change, eclipses, comets, aurora, any type of transient astronomical phenomena were usually seen in quite negative ways, almost universally. And interestingly, what also happens is red stars were also seen and given this sort of negative connotation and association. And that's particularly relevant to our discussion today. Now, there have been a number of research papers published by one particular team who made the argument that back in the ancient Cairo calendar, and they cite the specific one they go to, that there were descriptions that were very astrological in nature, that gave interpreted special meaning to these changes, and they had suggested that the ancient Egyptians had noted these changes in algal and had recorded them in their records. And they actually did a full analysis of this and made the argument that the periodicity, this roughly 2.8-day periodicity of that change in brightness, was actually recorded, which I found to be quite fascinating, this idea. And they had done their research and they had said, well, back at that time, the duration was a bit shorter than it is today. It wasn't 2.8. They had calculated through their analysis that it was shorter. And that actually fit some of the astrophysical models that said, well, these two stars are moving around each other, but actually moving apart. And that the reason they have a longer period nowadays is because they're moving out. However, I read a bit of research very recently that throws a lot of water on this. And the discussion, I don't know if anybody's involved in the history of astronomy. There's a Hastro listserv, which is very active, of historians of astronomy around the world. And this topic got brought up. And one of the guys had published a paper about this, which I read. And he found that what they were doing is they were finding an artifact in their analysis that just kind of happened to be around the same time period, this 2-point-something odd days. But he had explained it as a change in the synchronicity between the different types of calendars, like the lunar and solar calendars they were using. It wasn't that it came out as the period of the star Algol, that it actually was a relic that they'd attributed meaning to, saying, oh, that's what we're finding. It happens to be close to that, so therefore it's going to be. It shows one of the challenges with doing this kind of research. And I think this is an important lesson with this. I mean, I don't know if this team is incorrect, but the argument that was posed and published by the other scholar was very convincing and very detailed that this wasn't quite what the team were making it out to be. More research has to be done on it. But I think this brings up a really important element to doing all this kind of research. We are not studying the stars. We're not studying the structure of the stars. We're not studying things we can measure through spectroscopy or through photometry or some other scientific method. We are studying, in this context, how humans have observed and understood and interpreted the cosmic realm, how they have shared that knowledge, and how that knowledge has been passed down. Those are two very different things. What that means is the rules and methods by which you do scientific research can't just be planted on top of the cultural research and expect to have the same outcome. It's not the same thing. You want to be rigorous in what you do. You want to present your arguments in any scholarly way, of course, but we have to make sure we're not conflating the scientific methodologies with the social scientific methodologies. And I tell you right now, in the world of physics and astronomy in particular, that happens all the time. There's a lot of physicists who assume that, oh, we're the sort of top of this, or base of the scientific pyramid, whatever that stupid thing is, which doesn't actually apply. But, oh, we're the best of the sciences. Therefore, we know the most. Therefore, whatever methods we utilize are the best methods. And we can apply that to other academic disciplines, and this should be fine. So I should be able to take the methods I use in astrophysics and apply it to linguistics or anthropology or to political science. And that doesn't work. It's a very arrogant position to have. It's a very misinformed position to have. And I say that as an academic in the physics department. But the history of astronomy is rife with this kind of crap. And it's one of the reasons that cultural astronomy and archaeoastronomy in particular have suffered bad reputations, is by scientists and engineers trying to go into the social science world, not learning anything about social sciences and humanities, and thinking that, oh, who cares? I know how to do things properly. I'm going to apply my methods to that. That is an issue, and it's one of the foundational ones that we have to get through. Another thing we have to get through is this juxtaposition between myth and science. Myth and science are not two ends of a particular spectrum. There's not science on this end and myth on that end. They're not even on the spectrum together. It doesn't make any sense. When we do scientific research, we do our work, How do we communicate that information? We scribble it down, okay, but what do we do if we want to get it out properly? Publish it. Do journal publications, maybe books, but we write it down and we pass that information on that way. Whenever we teach a class, yes, somebody will get up and they will ramble on forever like I'm doing now, but you give the students readings, you give them papers, you give them textbooks. Humans have been around for 300,000 plus years. It's only been the last, 6,000 or 7,000 years we've had written language. You're ancient world studies and linguistics. About how old is written language? Yeah, 5,000 years compared to 300,000 years plus, right? Plus, there was never a time when modern humans, like we just went from like Denisovans to modern humans or something. It's a gradual evolution, right? But the point of that is, throughout our last 300,000 plus years, we pass on information through oral tradition. We practice it, we learn about the environment around us, we have our social kinship and our social rules, we learn how those systems are integrated, how they work together, and we practice, and we teach that knowledge, and we pass that knowledge to successive generations through song, through story, through music, through art. All the things nowadays that are considered, oh, that's on the art side of campus. We don't do that stuff in the sciences. Myth simply are stories. That's all they are. Myths are stories. So to say you have science here and myth here, and we're not going to be teaching myth as science, makes no sense. Myth is a form of knowledge transmission. It is not knowledge itself. That'd be like me saying, well, I'm not going to teach a book as science. That doesn't make any sense. The book may have science, may be completely about science, and maybe nothing about science, maybe it's somewhere in the middle. But saying myth and science are opposite ends is like saying science and books are at opposite ends of the spectrum. They're not. Myth is mnemonic. It's a way of being able to remember information and pass it on to successive generations. And we do that, like I said, through song and story. So in the context of Aboriginal Australia, and this applies pretty much universally around the world, everything around you has a song, it has a story. Doesn't matter how big or how little. And that's an important thing to remember here when we talk about this. Little can be small, it can seem insignificant, it can be very subtle. It has meaning, it has importance, and it's described and it's discussed. And everything has a song, everything has a story. In this particular community, 70% of all the songs and stories related to the environment, to the animals, to the plants, weather, and astronomy. So we have, I've just touched on the idea that we've got these spoken stories and these traditions that are passed down. Are there people in these communities that are what we think of now as astronomers? Were there people in communities who specialized in that particular area of knowledge, of the stars, and what that told us? Through calendars, through navigation, through timekeeping, through maps? The answer, of course, is yes. I use this quite often as an example. This is one example from the Torres Strait of the Zugubal Mabaig. The Zugubal are spiritual people, or spirits' ancestors who became stars. And Mabaig is simply a Kalalaguya term for man. So literally means starman. They went through several years of intense instruction in the art of astronomy. They refer to it in terms of reading the stars, how you observe the changes and the properties and positions of the stars, no matter how subtle, and know what that's telling you. So there were people who specialized in that and then went through multiple levels of initiation throughout their lives. And they sort of had a particular ownership of, you might say, of certain areas of the sky and of certain stars. So this figure here is a Zugubal Mabaig. He's holding two stars. These are the stars, the parts of the sky that he's looking after, that he has an ownership of. And this weird looking thing here behind him, this is a warup. It's a traditional drum, sort of hourglass shaped from these logs. The drum head is usually made of goanna skin. And those songs are the medium through which this knowledge is passed on. And they often look like the mouths of animals at the end. You can see the stuff coming out. That's the knowledge being passed through. So David Boson is one of the artists, or is the artist who made this particular artwork. He's from Moa. He's a Mualgal man. His father and his grandfather were trained as traditional Zugaba Mabaig. And he's actually one of the co-authors of the first astronomers that I wrote. And this applies in cultures all across Australia, across the Pacific, around the world. You had people who specialized in astronomy and in that particular type of knowledge. So what I'm trying to do here is set everything up for you to understand how we go about doing work in variable star research. So one of the reasons, one of the ways that we know how extremely subtle changes in the sky were observed and utilized and assigned meaning, one of them is to look at twinkling stars, scintillating stars. Now, as astronomers, how many of you actually do astrophotography or try to take any kind of data, right? And what's something you hate? You hate twinkling stars, right? The scintillation is a problem. We spend huge amounts of time and effort trying to avoid it. We spend tons of money developing adaptive optics systems. We put telescopes up on high mountains to get up above the atmosphere. We spend tens of billions of dollars putting telescopes in space, all to get rid of freaking flickering of the stars, because that's something that is a nightmare for us if you're doing that kind of astronomy. However, First Nations communities do not see the scintillation of stars as a hindrance. It is an extremely important tool in your astronomical toolkit. If you know how to observe the way the stars twinkle, it can tell you a lot about the atmospheric conditions, and hence weather and seasons. And by that, it can tell you about the plants and the animals and the ocean currents and navigation. All of that is tied into stellar scintillation. And when I talk about stellar scintillation, and here's an example from Rusty Peters, a Gidja man. The Gidja are from the very tip of Western Australia. And in fact, Australia's very first Aboriginal PhD in astrophysics, Stacey Mater, is a Gidja man. When you start learning about all the traditions around the world of twinkling stars, they're telling you all kinds of very subtle things you have to look for. How fast the stars twinkle tell you the wind currents. Do they twinkle quickly or slowly? But it's also, are the stars subtly changing color? Are they changing in sort of sharpness of resolution? Do they look kind of fuzzy? In some areas, they appear to have tails in the direction of wind blowing, especially in more Arctic areas. There's this whole body of knowledge tied in around how you observe all those subtle changes in stellar scintillation, how you tie them with other things you're seeing, such as moon halos or cloud formations, how to know the humidity and the air pressure, which you can feel, how to observe what the animals are doing, what directions the wind going. All these very subtle things around you, you have to observe, you have to understand, and you have to work out what they're telling you. And this isn't just some interesting novel thing you can do, it's a matter of life and death. If you know how to read the stars and it's telling you don't go sailing because the wind or storms are going to, work against you, and you go do that, you're going to die. So stellar scintillation was very predominantly used in navigation, but it applied to a lot of different areas. So let's get into the example I wanted to unpack today in terms of stellar variability. The records that we're going to go on are some historical records that were recorded about 100 years ago by an Irish woman named Daisy Bates, who for about 3 decades lived with different Aboriginal communities, spent a lot of time out at Uldea in South Australia, out in the Great Victoria Desert. This is what today we know as Kokatha country. But back 100 years ago, I think there were a number of people at that particular area who were brought from around the region. So it wasn't purely just Kokatha. But during that time, she had been learning a lot of local traditional knowledge and keeping a wide variety of journals and a fair amount of detail. This is one of the original resources from her hand, well, typed, written notes, pulled out from the library archives. And here's where you're going to come in. I want everybody to read this. There are a few sections where it sort of seems like, well, how come the text is missing? I did that on purpose, actually. And the reason I did that on purpose is a lot of the traditions bring in the sacred and profane, and some of them, by certain eyes, might appear to be very vulgar because they deal with sex, drugs, and rock and roll, basically. And it's not that I think that you're too immature to be able to handle that or anything, but in some cases, it's not always appropriate to be showing those elements, even though it's not going to take much for you to figure it out. But I want you to read this. The constellation Orion is known to the Central Australian natives as Nairuna, a name which seemed to have been linguistic affinity with the Orions. What she means by that, it's a very common name shared around the region. Nairuna, Nairu, Wati Niru, Wati something meaning man. Nairuna, Wati Niru is a hunter, but only of women, and he's a baffled and humiliated hunter, kept forever at bay by Kambugada, which is represented by the V shape of stars in the head of Taurus, the bull, the Hyades. She doesn't say the Hyades, but that's what she's talking about. Everybody knows what stars we mean, right? The elder sister of the Yugarilia sisters, the Pleiades, whom Nairuna, the man in Orion, is forever trying to capture and possess, but they are so well guarded by their older sister that he never has been able to reach them. Now, this kind of immediately reminds you of the position of these stars in the sky. Orion's chasing the sisters of the Pleiades in the sky. What's preventing him? Taurus the bull, right? Which actually isn't described in the myths of the Greeks, but in the sky, that's kind of how it serves that purpose. Kambugada always stands before him. Her left foot, Aldebaran, is filled with fire magic. What color is the star Aldebaran? Yellowish red, so it's a red in-class star, right? It's filled with fire magic, which she threateningly lifts each time she sees Nairuna's right hand, says the right hand Betelgeuse, endeavoring to put red fire magic into his club. So he's holding a club in his hand, and he creates his fire magic in his right hand to try to get her out of the way. And her left foot, full of fire magic, she uses to counteract him. She dares him with her whole body and is so contemptuous of him and his vain personal display of his feathered headdress, his ochred body. So in a lot of Central Desert cultures, when somebody was going through ceremony, different levels, men would be covered in red ochre. They were also seen as, it's like dressing up in a Gucci suit, right? Bad analogy, but you get what I'm trying to get across. So she was very contemptuous of that, and his string belt and his whitened tassel. She was so contemptuous of him that she placed a line of puppies between her and him. It talks about this faint, waving line of stars between Orion and the V in Taurus. Let's just unpack that real quick. What do you think we're talking about here? Not the belt, the shield, right? Orion's shield. Those stars that make that big curve that he uses to defend against the Hyades. Now, looking at this, we're going to unpack some of it as we go. Why puppies? These are referring to dingoes. Why puppies? Oh, you big scary man, I'm so terrified you. I better protect myself, and then puts puppies out. It's humiliating because he's an arrogant womanizer chasing a group of young girls. I think right now is probably a time everybody can, see that. This is kind of the Epstein of the day a bit, right? That's what it's referring to. So she puts this up there in a mocking, contemptuous way. The puppy's parents and all the relations of the elder sister. So the Pleiades are the younger sisters. Their elder sister is Kambugada. She's the Hyades. They stand, there are these other stars sort of surrounding them, and stars up in the sky, and they're watching what's going on. The younger sisters, the ones of the Pleiades, they're very timid. And whenever they see his body, his arm, reddened with fire and lust, which she referred to, because she doesn't know much about astronomy, she says, radiations from nebula? As astronomers, what's a radiation from a nebula? Does that make any sense? If you were not an astronomer and somebody came up to you and said, radiations from nebula, is that something you might buy? Probably, yeah, right? So this is coming from somebody who's got, they got some kind of an understanding of astronomy. They can name stars in the sky, they can name constellations, but they don't know astronomy that well, right? So she's kind of like, I don't know. It keeps talking about his body getting reddened with fire and lust. She's like, I don't know. I guess radiations from nebula. It says the fear comes upon them, and they change into the Mingari. The Moloch Heridius. Anybody know what the Moloch Heridius is? It's a species name. Anybody know what this animal is? It's out in the Central Desert. It's about this big. It's covered in spikes. It's a lizard. Close. Sorry? Thorny devil. That's it. Yep. And if you notice something about the thorny devils, what do they do when they get scared? Well, that's a different animal. They've actually got this big chunk of fatty flesh in the back of their neck. And what they'll do is they'll tuck their head down to protect themselves. And that looks like a second head. So whatever predator will think that's what they're going to attack. It's a defense mechanism. So across the whole central part of Australia, the Seven Sisters are related to these lizards. They say, while his rage lasts. Just that line, what does that mean, while his rage lasts? So he's creating this fire magic in his right hand, in his club. And he's trying to get her out of the way so he can get to the sisters. That's what he's trying to do. And she's preventing him by mocking him, humiliating him, and using fire magic in her left foot. Right? But while it lasts, what does the term lasts? What does that indicate? That at some point it's going to stop. It's not permanent. It's not like that's a red star, it's always there. There's something about that that is changing. Right? But the elder sister never changes her defiant attitude, and she can emit fire from her body so that the red fire of her anger and her magic is so strong that it can subdue the fire magic that Niruna throws out. And when she advances towards him, lifting her left foot, she frightens him so greatly that the fire magic of his arm becomes faint and dies out for a while. What is this telling you? The intensity of the red light is changing. Does this sound very ambiguous? It's giving an appearance of something, a brightness, specifically red, specifically tied with fire and lust, right? And it's giving you a temporal element to it. So you know exactly where it is in the sky, you understand the dynamic, and it may not tell you exactly how long it is, but you know that it changes over time. And you know it's short enough in time that people are going to notice it and give it meaning. There's only 2 pages. This is the second one. This is not everything, but we don't have time to do all of that, right? Again, Niruna's magic comes back in great force. So it went away, and now it's come back again in great force and brightness. And when Kambudika sees the strong magic in the arm and body, she calls to Father Dingo, and she doesn't identify the star, but she says it's a star on the horn of the bull. So we know the part of the stars, the V shape of stars, is her. And I don't want to be vulgar here, but her intimidation of him is basically trying to detract away from her sisters. And she's like, oh, come pay attention to me, right? So it's probably one of the stars in the Greek constellation Taurus that represent the tips of his horns. It doesn't say which one, but it gives us an indication. It says the father dingo, the father of the puppies, comes to humiliate Niruna, and Baba and the dingo rushes over to Niruna and shakes and swings him around. They come and they attack him. They physically attack him in the sky, moving him around. And they point, and all the other stars are pointing and laughing at him and mocking him as the young sisters hide their heads under their little mountain devil neck humps, like I was mentioning before. And then eventually Bob was like, okay, you've had enough. He loosens his hold and returns back to his place. A great portion of the stars and constellations surrounding Orion form part of this big narrative, this big myth around, including Procyon, Achernar, and other stars in Taurus. And all the other stars are ready to help the elder sister. They resent his womanizing, his humiliating position that he puts them in, and they laugh and mock him. And they support her because of her care for her younger sisters, the stars and the Pleiades. So you can start to already see the social lessons embedded within this. You start to see some of the science behind it. It's not described as science or in scientific terms, but you know by the diurnal motion, here's the Pleiades, here's the Hyades, here's Orion, and they're moving in this direction. They're in continuous pursuit. She's between them. She's supporting him. It's describing the relative positions and their relative movements to each other across the sky. Even some of the stars like Canopus, the owlet nightjar, the only an onlooker laughs. Now, what do you think laughing is referring to? What do you mean laughs? How does he laugh? What do you say? Twinkling. Yes. Very common to refer to twinkling stars as laughing. They're active. Some kind of dynamic motions going on. Sometimes singing, but laughing is a very common one. As he watches Kambuda blazing all her charms before the baffled Niruna, daring over him forever. Kara the redback spider, I've actually taken out the star that she identified because a PhD student and mine, Trevor Lehman, we published a paper a long time ago and we showed without fail that she misidentified. She actually put the star Rigel. What do you know about Rigel? It's blue. And she talks about Kara the redback shining redly. Well, sorry, that star's never going to shine redly. But the way that she describes else in her notes doesn't make any sense. It wouldn't be Rigel. It's actually the star Arcturus. All the animals and birds around her jeer loudly when they see Baba the dingo debasing Niruna's manhood, right? Even the moon mocks at him whenever he sits down beside Kambuda and her younger sisters, daring his journeys to the west. Just that line right here. What is that talking about there? Journeys to the west. When he sits down beside them. What are we talking about here? If you're looking up at the sky, Orion, the Hyades and Pleiades, how are they aligned in the sky relative to where the moon's going to be? They're very close to the ecliptic. And we know the moon's going to be in that, 5 or 6 degrees on the other side of the ecliptic, that zodiac pathway pretty much. So the moon will often go past them. Sometimes it will even occult them. It'll eclipse them, right? But that's showing how they come together. That's another element of that science of the observation. They're noting how the moon and oftentimes the planets and the sun are all in that pathway where those sisters are and these other stars. And we know that because, I'm not going to ask who in the audience's star sign is Orion or Taurus, but I'm sure some of you are, right? See how much I know about astrology? Taurus is one, isn't it? Yeah. Taurus, that's what I meant to say, Taurus. Listen to what I mean, not what I say. Who's Taurian? One person's raising their hand. Good. So you can say on fine, bright, starlit nights, the old men of the central desert groups would watch the game between them, and you'd sort of see this dynamic played out. And there's this whole big ceremony tied into this, and there's a lot of secret elements to this, and the story goes into a lot more detail, but we're not going to share that because a lot of that is quite restricted knowledge. But the point we're getting across is you can see the dynamic of the narrative. And one of the main elements of this narrative is that these 2 red stars in particular are changing in brightness over time. Now, I don't know if anybody happened to see the exhibition. Has anybody ever heard of the exhibition of song lines tracking the 7 sisters? I highly recommend checking it out. It's a traveling exhibition going around the world where a bunch of elders from the central desert created a huge exhibition, a planetarium show, sculptures, shared knowledge, all about the largest and most significant song line that goes all around Australia, from coast to coast, all the way around, which is the song line of the Seven Sisters. This goes from Western Australia, all across Central Australia, to Byron Bay, all the way down here to Melbourne, up to the Grampians, up through Hindmarsh Island, all the way back up, and loops around all of Australia. Middle of last year, I held a conference at the University of Melbourne. It was called Indigenous Astronomy in the Space Age. And the post-conference excursion was to the Central Desert. We went to Uluru, we went to Norla, Henbury, went to a few other places. And we had one of the traditional custodians named Vincent Forrester. And Vincent is one of the TOs, and he started off when we were in Alice Springs talking about this, and he was talking about it and naming all the places, and he was naming places around Victoria, he was naming Hindmarsh, he was naming parts of Queensland, showing the track the song line went around the country. When we got to Uluru, he took us off the main trails back to areas where there are star charts engraved on the side of Uluru talking about the Seven Sisters story. This narrative, these stories about this, which as far as the depth of knowledge are relatively shallow, even though they do give a lot of information, because a lot of that is restricted women's business. But they do show it even in the animations. Not only, and I'm sure it's crossed multiple minds, Orion is seen as upside down. How does that make any sense, right? But it shows that in here, it shows the sparks, this discussion of the fire or the reddening of Nairuna's arm. It shows that in the narrative. Let's start to unpack this. Stars of Orion. Orion, you know, familiar with the Northern Hemisphere view, but down here, of course, he's upside down. Now, this is something that when she first started publishing her stories in newspapers, which was very common practice back in the day, readers were looking at this and saying, now, hang on, this sounds like all the Greek traditions. I think what's happened is the Aboriginal people have heard about the Greek traditions and just made up their own story about it. And she's like, no, that's not the case at all. They don't know anything about the Greek traditions. They've not had an exposure to that. These are all independent, and they've got huge amounts of knowledge that have been around way before we ever came here. And they say in the traditions that he's upside down. In the dome show of this, it shows him upside down in the sky. In central New South Wales, in the Wiradjuri communities, they describe the great creator as the stars of Orion, and he's upside down in the sky. They say he was hunting an emu and he tripped and fell over the horizon. And they actually show some of the ceremonies with him flat on his face. Now, something else you might notice when you're looking at that, you see the belt of Orion. You might notice something else about the scabbard of Orion that's not a scabbard. In the old traditions, that was never a scabbard. That was something that was kind of cleaned up by the Victorians and their prudishness, right? That's described in the Aboriginal traditions in the same way. Interestingly, some communities describe this as a man, same shape, but he is standing up. And if you look at these stars, it can kind of be seen both ways, right? It's not like it's something that's so distinct, if you flip it upside down, it totally changes. It's got symmetry to it. So this is where we can start to map out these stars in the sky. There's Aldebaran and the Hyades. We got the Pleiades, of course. This is an image where this was Venus when the image was taken. The stars in the sky, the shield of Orion, those are the puppies. We've got Nairuna. We've got Betelgeuse. Betelgeuse and Aldebaran are both extremely bright first magnitude stars. They're also very distinctly red. They've got a very high color index, which shows they're very red. They're noticeable. Am I out of time already? Who was that? All right, good. I know I'm taking a bit of time, but I want to go through this methodically with you guys. All right. Now, I mentioned before the color red in astronomy has special significance. There's not much in the sky that's red. How many, now we do know, maybe all the astronomers in the audience, what's the most common star in our galaxy? What type of star is the most common star in our galaxy? Red dwarfs, right? How many of them can we see? Almost none of them, all right? The closest star to our solar system is what? And can we even see it without a telescope? What is it, magnitude like 9 or 10 or something? It's the closest star, aside from the sun, we can't even see without a telescope. How many of the stars in the sky that are noticeably red do you think are, percentage-wise? How many of the stars in the sky do you think are noticeably red in the sky? Who says over 20%? Who says between 10 and 20%? Who says between 5 and 10%? Who says under 5%? It's about 3.6%. Well done. Just over 3% of the stars in the sky are noticeably red. Of the really bright ones, again, it's not very much. So the red stars have a special place in the sky, special meaning. And when you start to look at the traditions about stars in the sky, yes, brightness matters, but not always. Color matters to a degree, but only really between red stars and non-red stars. In fact, if you go to the Central Desert, the Luritja people divide the sky in half through the Milky Way. They say this side is Luritja, this side over here is Aranda. The other way around, this side is Aranda, this side is Luritja. But also they have a stellar classification system. And the names, I forget the names off the top of my head, but they describe red stars, white stars, and reddish white stars. That's what they consider to be important. So let's start to look at Betelgeuse, right? So it talks about this star brightening and fading. What do we know about it? Well, we do know that Betelgeuse is definitely a variable star. Here's a light curve of it. Now, we can see that it changes by almost 1.5 magnitudes on average. Now, that's quite a bit. That's very noticeable to the naked eye. Now, you look at this light curve over time, you kind of notice there's a main period where it kind of dips, comes back up, but there's also kind of another period in there. You can kind of see this background sinusoidal wave in there. What happened here? Well, COVID did happen there. Very good. I'm sorry? Yeah, what do we call that? The great dimming of Betelgeuse, right? So you may remember this. This is a picture, I found this online, I loved it. One where somebody took a photograph in 2012 and then they took the exact same photo in 2020. It went from being the 11th to like the 23rd brightest star in the sky. Don't quote me on that, but something along those lines. Dropped noticeably in brightness, but you can very clearly see on the light curve, all right? Now, I want to bring in one more tradition, and I'll let you read this off of here. This is something, because we're getting ready to start unpacking, well, how do we know? How can we even be sure? Can we observe the variability of the star? What does this entail? We're going to unpack that in a second. Before I do, when I first published a research paper on this, I sent it to one of my PhD students, Bob Fuller, who's now Dr. Bob Fuller. I just said, would you mind just reading over my paper before I send it? Are there any mistakes you can catch? I do that with all my students and colleagues. I send it around just to see if anybody catches any screw-ups on my part before I send it out to reviewers and get really embarrassed. And he says, you're not going to believe this. He actually called me on a train. I was in Sydney at the time. He called me. I was on the train, and he says, you're not going to believe this. I'm like, what? He's like, I just sat last week with Uncle Dennis Foley, who's a professor, and he was telling me about one of the stories they have from up near the Canberra ACT region. And he talks about how basically there was a family and there was some big war with the neighboring community, and only a small family survived that. And they decided to ascend up into the sky to avoid being killed. So there's a couple daughters, and they went up into the sky. He says, but you can read it, but he said the important thing is the father, who was the last one to be pulled up, he had been injured, he was bleeding, he was red. He said the son pulled him up into the sky, where he's the red star in Orion. He didn't say Betelgeuse, he says he's the red star in Orion, which pulsates slowly. This isn't an historical account written by some white fella who happened to here's something from the Aboriginal people. This is directly from the source. This isn't an elder who's got a background in astrophysics and thinks he's going to impress some astronomers by talking about variable stars. That just isn't on the radar. He talks about this and describes that star as pulsating slowly, which I immediately found interesting because an old astronomer named Wick back in the 90s wrote a couple of publications looking back through ancient historical records and myths about stars and found several of them describing Betelgeuse and flowing blood, which I thought was interesting, which to me just seemed like Betelgeuse sort of twinkling a bit, right? But this was interesting. He literally said it pulsates slowly. This begs a question. Is this something that's detectable? When you're doing research, you have to consider all options. When I first read those stories, the thing that came to mind for Trevor and myself is she describing a variable star? A researcher who'd done a little bit of work on this for a master's degree a few years before had mentioned that this had been done, although she identified it as the wrong community, but she did say, maybe this is describing the variability of Betelgeuse. And I'm kind of like, wait a minute. People can detect that without telescopes? I had just done a master's degree basically on variable stars, but never thought about standing outside and looking at the stars with your naked eye. For me, it was just big data chunks. And we started looking into this, and we initially said, nah, that's going too far. I don't believe that. That variable stars, really? I don't think so. And we threw it out. And we thought maybe it was a meteor shower, like the Orionids. And the source of the Orionids is not far from Betelgeuse. We thought maybe it's something else. We didn't give it much thought. And then went back later, and I was reading this. We were doing a second paper on Daisy Bates's records of all this stuff she had done, and we're like finding more stuff she had written. It keeps talking about what you just saw. This start changing in brightness, coming back even more powerful. We're like, hang on. This very clearly seems to be describing it. Is this possible? If you're going to observe changes in the magnitudes of these stars, like stellar variability, what's the limit of your vision? If you're an inexperienced observer, you can get about 3/10 of a magnitude. That's about the limit. For the experienced observers, for people who are out looking at the stars on a regular basis, 1/10 of a magnitude. That's a very small change. In fact, if you look at the 3 stars in the belt of Orion, you don't notice that 2 of those stars are almost the same brightness, right? You know what those stars are? I don't remember off the top of my head. Yeah. Yep. That's right. But they're not the same brightness, but they're almost the same brightness. But if you take almost anybody and you go outside, can you tell the difference between those two? It's about 1/10 of a magnitude difference between them in brightness. And most people would be able to correctly measure that. Are you taking notes on this? You should be, because this is one of those things we'll be looking at, right? Daniel's a master's student with me working on dark skies and looking at the effects of light pollution. That's one of the things that'd be interesting to tell, is if you can actually discern the brightness of the stars. Well, what about Betelgeuse? Well, Betelgeuse varies by 1.5 magnitudes, not 1/10 of a magnitude, by 1.5 full magnitudes. Without question, very obvious, yes, you can see that change just in the brightness alone. Well, how would you even measure it? Are you just looking at a star in isolation? The answer to that is no, you do what a lot of amateur astronomers would do, because we know most professional astronomers never look at the sky with their eyes, right? And the same thing that people like Herschel did. You have to compare stars. So what Herschel did for a while is he wrote down a list of all the bright stars in the sky in order of their brightness. And he did that several times. And if any of them are changing, then the order of some of those stars is going to change on that list. Now, he did that over a course of 4 years between the mid-30s and 1840, and realized that some of these stars were changing in brightness. And Betelgeuse was one of them. So what you need to be able to do that are easily usable nearby reference stars. And there are lots of them around Betelgeuse. Capella, Rigel, Procyon, Pollux, Adhara. You've got several first and second order magnitude stars. I mean, these are pretty much all first order magnitude stars that are relatively nearby that you can look at between them and you can tell quite easily, right? So you've got that. We passed that test. Okay, what are the time scales? I said before that a lot of variable stars have such long time scales, you're not going to notice them. Would you know it over the course of like hours, like you would Mira, or Algol, I'm sorry, Mira, where it might be, you know, a few months or half a year, or is it something longer? Well, that main change in the brightness of Betelgeuse, those dips we saw, occur on the order of 400, 420 days. So around every 13 to 14 months. Now, how long is Betelgeuse visible in the sky? About half the year, right? Which is about half that. What that means is when Betelgeuse first becomes visible in the evening sky around the end of November, start of December, roundabout, you're going to see it at a particular brightness. Even if it's just rising at dusk, it's going to be high in the sky later on. Now, as that 6 months goes by, when it's about to set, you're still going to see it. You're going to notice enough of a change, you know, because that 1.5 magnitudes will be changing over that time. Now, I know the variability of the star doesn't synchronize with the calendar that we're going to see it, but the point is, over that 6 months, you are going to notice a change in the brightness of that star, right? So does that check out? Yes. It's visible for half the year. You're going to notice those changes if you're paying attention to it. And we know that Aboriginal people and Islander people were absolutely paying close attention to the stars. They had people dedicated to spending their time looking at those stars. And in particular, those stars, there's whole giant myths and narratives and ceremonies tied around those particular stars. Of course, people were watching them. What about the dreaded Purkinje effect? Who knows what this is? Anybody ever heard of this term before? All right. So we've got two types of photoreceptor cells in our eyes. We have the rods and the cones. The cones sense color, mainly. This is a kindergarten version. They sense color, and they're towards the center of our retina. And we have the rods, which basically sense light and dark, and they're more on the periphery. Now, I'm sure many of you have noticed that if you get away from white light and you adapt to the dark, it's hard to see something when it's directly in your eye. Often through your telescopes, you slightly look away, right? You can see it hitting those cones that are, or those rods that are on the periphery of your vision. I always remember this because when I was a child with my parents, I was a super nerdy, aspy kid back then, just as I am now. I remember we were driving out in the country somewhere, because we lived out in the country. My mother said, "Look at that little group of stars up in the sky there. How come when I'm looking at them, I can't see it very well, but when I look slightly away, I can see it really well?" I didn't know the answer to it back then, but I figured out what it was. She was looking at the Pleiades, and for this exact reason. So what happens is when you have your day vision, your photopic vision, your cones are mostly working, you can see color. Your peak sensitivity is towards a green, yellow-green, right? Which incidentally is the peak of black body radiation of the sun, right? However, once you adapt to night vision, your scotopic vision takes over. Your rods take over during that. And then your peak sensitivity is towards the blue-green. It gets moved over. What that means is you're less receptive to red light in your night vision. So if you look at this, was named after a Dutchman named, Peter, how do you pronounce that name? Purkinje. There we go. I totally Purkinje. Jesus. Jan Purkinje. Okay. So he actually never mentioned anything about this in his big book on this effects in terms of astronomy, but it came to be understood that your sensitivity is going to be reduced. In terms of astronomy, this makes red stars appear fainter than blue or green, I say green stars, blue-green colors of blue stars, and their other stars are going to be relatively brighter. So it's going to dull your ability to see the red light. Now, years ago, when I proposed this research and I first published that, there was somebody who told me very pointedly that this effect proved that I was wrong. Couldn't be done. I was like, well, there's some issues with that. So it can affect your visual estimates of variable stars when you're using different colored comparison stars. So if you look at a blue star and a red star and you're trying to compare them, it's going to be impacted as you go from your day vision to your night vision. The issue is this applies to fainter stars beyond the threshold of your day-night vision. Day-night vision? Whatever. Oops. Your mesopic vision, that's your sort of transition. That's a combination of both the rods and the cones as you're moving from one to the other. Even in that case, that only applies to stars that are below about magnitude 3.1, or around magnitude 3. When the people are looking at it, you can see it clearly. If it looks red and it looks bright red, then you're not using night vision. It's activating your cones. So those bright stars, the first magnitude ones, like Aldebaran, like Betelgeuse, like Antares, if you notice them and they look bright red, you're not looking at them through purely night vision. You're actually activating those cones and seeing them. We know that because they describe them as being bright red, right? So, that's it. So what we've looked at here, what I've hoped to have you guys kind of get involved in, is how we go about doing some of this research, how we go about interpreting what we're seeing and what we're reading. And this involves looking at other records and other stories that other people may have written about. There's a whole lot more research that goes into it than what we've just seen tonight. But I hope it's giving you some kind of an insight to how we go about this. It isn't just looking at something, getting a random idea in my mind and saying, I'm going to defend that to the death. You have to follow the evidence. You have to follow the logical trail of the evidence. And sometimes it can take you down the wrong pathway. That's happened to me. It's happened before. There's another story from South Australia that seems to be describing the variability of Antares, which is also another star, bright red star, that changes in variability, I'm done now, by over a magnitude, but the periods are like 4.5 years. It's a bit of a tougher one. When you go back and look, it's not clear they're talking about the star changing in brightness, even though it's kind of mentioned, but not nearly the same clarity that we saw with Betelgeuse. So I hope it gave you some indication of how that works. I hope all the students here on my research team kept detailed notes, right? Do we have any questions?
Thank you, Duane. That was wonderful. Now, do we have some questions? Yep.
Thank you. Just in regards to when you were talking about Orion, you mentioned that in most Indigenous cultures within Australia, he is depicted upside down from our perspective in the kind of same orientation as how the Greeks have him. Is there a generally accepted reason for why that occurred or how that came about?
I want to be careful about a couple things that I say. It's easy when you're talking like I am now to say, oh, most cultures say that. Well, a lot of Aboriginal communities talk about Orion being a man or a group of men, usually something masculine, and the Pleiades being feminine, and them chasing. Not always. The reason I say that is it's easy to make those kinds of claims that get universalized, right? When that's actually a little bit of research or selection bias. I'm recognizing those that fit with that description, and those are sticking in my mind, and you kind of ignore the other ones that don't fit that, right? But there are lots of traditions that talk about this. I think you would have known because you took a couple of my courses already. So one of the PhD students in our group, Bridget Kelly, she's working in psychology, and she's addressing the question is, why do the same groups of stars, why are they seen by different cultures in such remarkably similar ways? What's the reason for that? She's trying to address that question from the hypothesis that it's something about human perception. That's the way that we group things together. So this idea of Gestalt principles and the way we group things together and see patterns and familiar shapes in them, that has something to do with it. So she's been doing a lot of theoretical work and then applied work, and she'll be giving me a guest lecture for my class. Are you taking my Indigenous Astronomy class this year?
I'm taking your third year.
Right, good. She won't be doing that one, but so I don't know the answer to that. She's probably better at answering that one than I am, but there are a lot of remarkable similarities.
Thank you. I had a question in regards to the twinkling stars.
Yep.
And how the impact of light pollution on that.
Yep.
So I was wondering, like in the city of Melbourne, how possible would it be to do weather prediction by looking at the stars? Would I be able to, from my backyard, look up at the twinkle and see the wind, or like if it's going to rain or if it's hot, or like what extent does light pollution influence that?
So the interpretation of how you observe what those stars are telling you is going to be localized to that environment, and they're not going to be the same everywhere. They're going to be familiar. So what I mean by that, we know that stars twinkle because of wind, because of turbulence. So if you see stars twinkling, you know there's wind. If they're twinkling fast, there's heavy wind or turbulence. If they're twinkling slowly, it means a slow wind. If you go to the Torres Strait, you will see towards the end of the Nege dry season, you will see the stars twinkling very rapidly, even though the ground level wind is dead still. They say it's a doldrum. It's not moving, not a breath of air. But you see them twinkling. And they know there's a shift in the trade winds from the northwesterlies, which are hot, humid air, shifting from the dry southeasterlies. Now, the others know that's the case. And when I went to the Bureau of Meteorology to learn more about this, I found out in that area, when the trade winds start to shift, they do so at extremely high altitudes. So it's not happening down the ground level. But there are other communities where you would look at that and you would notice stars twinkling or the way they change color. And that's going to tell you about that local in situ environment. So what I'm getting at is, if you understand how to read them in Melbourne's weather patterns, and good luck with that, you might be able to figure it out. But you couldn't take what they do in the Torres Strait and transplant it here, because it might not work, because it isn't the same kind of climate or environment down here. But because the different cultures around the world are observing a natural phenomena that obeys the same laws of physics everywhere, right? You're going to see these similarities in these traditions. And that's part of not so much the grouping of stars, but the interpretations of the knowledge. Why are these systems used in similar ways? Because they're using science, and science applies everywhere.
Thank you. And so, like, ignoring the chaotic weather of Melbourne, does light pollution not affect that at all? I could still be able to.
Light pollution will affect it in a lot of ways, because it reduces what you can see, reduces your physical eyes, what you can see because of light pollution. It affects what's visible, plus all the me scattering that you're going to get from the dust from all the agriculture and mining and car pollution. All those things are going to impact it. So I don't know if the communities around here use stellar scintillation that much. Maybe they did. I don't know. I'm assuming they probably would have. So if you were here 300 years ago, you probably could do that. Good luck doing that now. But I'm not saying it's impossible. I just don't know how exactly it works. But the same principles you could probably apply. I've rambled on for a very long time.
Have we got some more questions? No? All right. Thank you very much, Duane.
Thank you.
Now, while Bill's setting up, oh, yes. While Bill's setting up, I'll mention a couple of things about what's coming up at the ASV. Next month, let me double check. On the 21st of March, we are having a Messier Star Party at LMDSS. Just remember, you do need to book your tickets to get along to that one. And there was an email sent out, ASV events, earlier in the week or late last week, that has links to purchase those tickets and get your space there for that. After this, after Bill's presentation, the library will be open, but I don't think we'll be using the telescopes over there tonight. No. So, all right, how are you going, Bill? No worries. The other thing to mention, in that same events email we sent out, the David Mullen Awards calendar that is available for $15, and it showcases all the images from the winners of the David Mullen Awards. So feel free to grab that. It is February already, but yeah, it's still a beautiful calendar. Bill's nearly ready.
Today's the 11th of February, correct? All right.
Good to go?
I think so.
Excellent.
See if this thing works. Yes, it does. Thank you. You can turn me off because that's the important bit up there. Okay. First of all, presentation tonight is being held on the lands of the Bunurong and the Wurundjeri Wurrung peoples of the Kulin Nation. I wish to acknowledge them as the traditional owners. I would also like to pay my my respects to the elders, past and present, and Aboriginal elders of any communities who may be here or watching today. I'm going to talk, as usual, about the general conditions about at this time of the year, and then I'll get into the what's in the sky. Then I'll get into the moon. There's quite a lot tonight, this month. Planets. There's a couple of planets of opposition. Guess what I'm going to talk about? TCRB. Then I'll get into the usual getting orientated visual suggestions, photographic suggestions and stuff for tomorrow morning. Finally finishing with things to look out for this month. So the general conditions this time of the year, it's late summer. It's been very, very dry. And you will have noticed that the nights are starting to get longer. It's about now that you can start to really notice it. You get up at about the same time, and it's starting to darken. So stuff like that. The retained heat, and of course global warming. That means that the air is going to stay warm for a little while, and that's the reason why summer sort of starts at the solstice. It doesn't centre at the solstice. It has been very dry over the last few weeks. It's nice to get a little bit of rain today. But now, speaking of twinkling, summer storms can help clean the atmosphere of the dust and smoke. So probably for me, the astrophotographer, the best time for my work is after a good rainstorm. But anyway, your mileage may vary. Don't put your binoculars away yet. Low magnification. I often tell people that high magnification is not always your friend. Especially in summer with the twinkling of the stars. I feel bad about saying that now. So, low magnification is what you need on a warm night. So sunset today is just before 8:30. Nautical twilight is just before 9:30. It's about an hour after. Sunrise tomorrow is 6:45, and it's again about an hour before. It's nautical twilight. Starts. Next month, the sun will continue to move, and so sunrise is at 7:15 and sunset is at 7:45. So we're starting to get the nights back again. For young astronomers, now I wrote this about a month ago, so I can't remember what I've said. It's the start of the school year now, and my wife is a teacher, and there's a couple of teachers in the room today. My teacher wife does not like grumpy kids in her class. So remember, you need a decent amount of sleep in the first few weeks of the term, please. Okay, for the Moonies, it's a fairly big month. This is an old image by Kelly. Is Kelly here today? She's not. No. Okay, for the moon the next few weeks, the new moon is on Tuesday the 17th. That's next week, I think. There's an annular solar eclipse if you're a penguin or one of the Antarctic scientists. It's partial in southern Africa, but we're not going to see it at all. You will be able to see the moon in a few days as a waxing crescent. This is all absolutely normal after sunset, so you look west. And it's moving out of the south this week. So when you see it, it's going to be getting lower in the sky because the north is like low in the sky from where. First quarter is on Tuesday the 24th. First quarter rises at noon and sets at midnight, so it's an evening thing. That's when you want to have that star party. So that way you can see a bit of the moon, and then it buggers off and you can see a bit of the stars. So over the following week, it's going to be waxing gibbous, so it'll fatten up. It's crossed to the north on the 20th, which means it'll stay low in the sky over the whole week. There is a lunar X. Lunar X is there. There's actually a lunar V as well in that photograph. That's that one, I think. So there's a lunar X on Tuesday the 24th, same day as the first quarter. It's at 18:31, which means that the sun will still be up. So it's going to be a bit of a challenge to see, but yeah, anybody who can get a photograph of that, good work. Okay, full moon is on the 3rd of March, which is, now that's right between perigee and apogee, so it's called officially a near moon. It crosses to the south on the 5th, so it's going to be getting higher again. And over the following week, it's going to be setting in the early morning as a waning gibbous, sorry. Now, hang on, I'll just go back. There's a total lunar eclipse, and that's obviously where the positive declination and the negative declination of the sun are the same. Sorry, the sun and the moon, they're at opposites, and that's at the time of the full moon, which is at full illumination. So that's where that's in that graph. That's where a lunar eclipse happens. Okay, there's also this is a photograph of the total lunar eclipse. Please calibrate your images when you get photographs of the lunar eclipse. I've got a nice photograph, possibly an example of what you shouldn't do at the end. Last quarter is on Wednesday, the 11th of March. It's deep in the south, so it's going to be very high in the sky. And last quarter rises at midnight and sets at noon, so it's a morning object. And then it becomes a waxing crescent, gets thinner and harder to see as it approaches the sun. So that's the moon stuff. Planets. Mercury is an evening object. It's going to be really hard to find this entire cycle. It doesn't really get out of the evening twilight, so that's a very difficult one to get. Venus is also an evening object, and it sets before 9 p.m. It's even closer to the sun than Mercury, so you've got Buckley's with Venus at the moment. Mars is now a morning object. It's just changed over. It rises about 6 a.m. It's about a half hour before the sun, so it's again a bit of a tough ask. It's moving very slowly. You can see in the thing at the back of the yearbook, Mars is like going almost flat along nearly the whole year. It's going to be just dawdling along. Jupiter is now past opposition, so it rises before sunset. It's high in the sky, approaching the meridian at about 10 p.m., which is a really good position for viewing. Saturn, it's probably, if you can see it at all, it's pretty much your last chance. So it sets just after 10 p.m. So it's almost gone now. Uranus is it's still good evening viewing. It's just after midnight. It sets just after midnight. It's still close to the Pleiades. A little bit higher than the Pleiades actually. It's about that yay much above. It passes the meridian at 7:30, so it's in a good viewing position pretty much early on in the night. Neptune is still near Saturn. Those guys are going to stay very, very close for pretty much the whole of the year. So if you can find Saturn, you can probably find Neptune. It's a tough ask though, because they're both getting close to the sun. Pluto, if you're into Pluto, it's a morning object. It's rising just out of the twilight. Very hard to see at the best of times, even harder right now. So it's not an amazing time for the planets. Jupiter's your best bet. Jupiter opposition. Got a couple of planetary photographs from members. So this is originally from last month. We didn't have a meeting last month, so I didn't get to present it. So Andrew Hamacher has got a nice little photograph of. I don't actually know what moon that is. Probably Io. I don't know. Mark Justice has got a great red spot. And Conclavis, that's a nice photograph of a shadow there. So this is typical Jupiter stuff. And George Schwab has come to the party with I've got a photograph of George Schwab's Uranus or something. But there's Uranus is mooning. There's lots and lots of moons. There's Titania and Oberon and all those things there. Okay. Now, I thought long and hard about bringing this one back because T Corona Borealis is resolutely doing absolutely sweet FA. It's not quite in a viewable position yet, but what I've decided to do is show you when you can see it. So until March, forget it, it's too close to the sun. It's viewable in March before sunrise, and April, May, June and July, sort of throughout the evening, throughout the overnight. And August, it's in just after, it sets just after sunset. That means that if we are going to see it it better happen April, May, June, or July. So, anyway, that's my little barrow that I had to push about T. corona borealis. It's going to go off at some stage. So, yeah, that's a cataclysmic variable. So I don't know if Ryan's still here, but yeah, it's one of the things he didn't talk about. Another thing, we've got this. We've got MAPS, the sun grazer comet that is on the way in, and it's going to come down there. This is looking due west. Right at the moment, actually. Well, this one's in April, which is 2 days, I think, after it's closest to the sun. What do they call it? Peri something or other. Anyway, it's going to come in pretty hot, and it's going to come out again maybe. So it was discovered in January. It might be bright. It's already got a tail. There's a couple of photographs of the tail out there. So it's going to hopefully brighten, but who knows what it's going to go. It will approach the sun really, really closely. It's 0.03 astronomical units on the 3rd or 4th of April. However, it's going to go either one of two ways. It's going to be really, really cool after perihelion, or may not come out at all. So we just don't know. So that's something to keep an eye on, but it might look really cool. For more details, check out the Comet and Meteor Section Facebook page, because anything that will be photographed will end up on that. Okay, so getting orientated. I'll see if I can rattle through this fairly quickly because the night's getting a little old. I've got a lot of things I should rattle through them. The three major signpost constellations, there's only two visible at most of the time. We've got the Southern Cross, it's about 9 o'clock on that little clock, which I will get rid of. And so the Crosses area, which is that area, where's my little thingy? There. This area here is coming into a really good position, and there's a whole lot of stuff that is good in that area there. Orion is just past the meridian at 10 p.m. So that's your other signpost, and obviously Scorpius is not currently at the party. Major stars, we've got Canopus, which is before that leads the cross, and we've got Achernar, which is opposite the cross, or possibly leading Canopus. It doesn't really matter. Is it Canopus? I don't know. It doesn't really matter how you remember that one. Fomalhaut is just about gone. Hard to see. You probably won't actually see much of that, even if you're looking straight at it. Sirius is bright as anything, and it's approaching a meridian about now. It's close to that donut hole that I've been talking about in the last couple of months. But that's the zenith where you can't easily point a telescope. Procyon it follows Betelgeuse. Now, Procyon means before the dog in Greek culture. Oh, I think it's Greek culture, but that only works in the north. It doesn't rise before the dog at all. Aldebaran, which is you hop over Orion, is very close to the meridian, and it's a nice yellow star. And Regulus is we need to have a star in the east, so there's Regulus that's rising in the east northeast. Saturn is pretty much gone, and Jupiter is in a good position before the meridian. Okay, visual evening targets. Let's see. Jupiter, obviously. 47 Tuc is just about on the way out. It's sort of, towards the end of its season. 75 Tuc, which is the other glob near the SMC. You're going to need a little bit more equipment to see that, but it's from a dark sky sight. It's quite nice to see. P Eridani is also getting towards the end of its run. Theta Eridani as well. It's a nice little double that. Pleiades this is probably the last month you'll have a decent look at Pleiades. Poor Man's double cluster, which I have talked about before. It's a nice little thing where you can get two clusters into one binocular shot, which is interesting. Sigma Orionis is there, easy to find. You can actually see it with the naked eye. Tarantula Nebula is well placed, about as good as it can get at 10 p.m. Beta Monocerotis is a triple. There's not terribly many triples around, so there's not terribly hard to find. It's not really obvious, but M41, I got a nice photograph of that the other day. Little beehive, that's not far from Sirius. 145 CMA, that's Southern Alberia. That's my personal favourite, nice coloured double. M47, if you're looking for another open cluster, is not far again. I like to have these on the east side of the meridian. M79 is on the west side, so it's proving me wrong. Gamma Velorum is pretty much as good as it's going to get. It doesn't get a lot higher than that. The diamond cluster, I thought I'd give you a couple down in the in this area. Diamond cluster and gem cluster, and I think that's it. So I'll probably go into that a little bit more detail next time or something like that. Photographic targets. Again, some of these are holdovers from last month, so there's quite a lot of them. Crab Nebula, Vela Supernova remnant. Daniel Horton sent me that photograph. That's really good. That's an enormous field. There's what's becoming known as the Dolphin Head Nebula, SH2308. That's a remote photograph. Another friend of mine, Paul Sanfilippo, has got a really nice photograph of the horse head. That's awesome. Wishing Well cluster from Stefan. Rosette. It's pretty much rosette time of the year. Barnard's Loop. This is an old photograph from Russell. I haven't actually seen Russell for a while, but this is again a very wide field. I think he's got hydrogen alpha in that because it doesn't stand out all that much unless he's really processed the crap out of it. Carina Nebula. I love this photograph. I love stitched together things, and I love it when they're stitched together from different angles. Just I don't know, there's something aesthetic about that. Cone Nebula. Hello, Gerald. I had to put one of his in because he's a competitor. Banana Nebula is also another one. I've never photographed a Banana Nebula myself. And Gabriella Mistral is just off the coast of the what do they call it, nebula? Carina Nebula. Bogeyman Nebula is a dark nebula, hard to get. So well done, Stephen. That's good. And Thor's Helmet. It's Thor's Helmet season. So it's another Gerald Grech photograph. I think that's it. Sorry, I probably put in well too many there. 5 o'clock tomorrow morning. The cross is just on the meridian. There it is. And Orion has now gone nine-nays, but Scorpius is getting high in the east. Tomorrow morning, it's going to have a dirty great moon in the middle of it. So well, it's not actually dirty great moon, it's a part, but whatever. There are no planets. Isn't it tragic? There's no planets for the early risers. So there's nothing for my dog to bark at 5 o'clock in the morning. So final notes. There's a lunar X on the 24th of February. Don't forget that. The moon and Regulus are in conjunction on the 3rd of March. It's a full moon, which means Regulus might disappear and might not even come back because you can't see it the full moon. Remember the total lunar eclipse. Now, please, like I said before, calibrate your colour images. This is from a genuine advertisement that's going around at the moment. Colour it's not that colour. Antares is very close to the moon on the 10th of March. Jupiter is stationary. That's the end of retrograde, which means that Jupiter is going to stop and go back the other way. That's on the 11th, and there's some sort of astrological meaning to that, I think. The 13th of February is Giftland Star Party, and that is it. All right. Okay. Are there any questions? No.
Are there questions for Bill? No?
What is the airspeed velocity of an unladen swallow?
All right. So thank you everyone in the room for coming along tonight, and thank you to everyone that's been watching online as well. I'd like to say a very big thank you to Duane for coming along tonight and presenting. Yeah, it's just wonderful. We've had some fantastic comments on Facebook and wherever, so thank you very much for that. Thank you again to Lee, doing all the AV techie stuff that makes all this happen. And thank you to all of you. Have a wonderful evening and get home safely.